Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present about mini project engineering economy. Our title is Manufacture of Chitosan Base Coating. This is my group member consists of Muhammad SAIROL, Muhammad Basid, Muhammad AMJAD, which is me, and Muhammad FIRDAUS bin SAINUDDIN. Now I will continue on the introduction part, which is product description. Ensuring the integrity of pipelines is vital, but current methods using toxic chemical create a conflict. These chemicals effectively prevent corrosion, but harm the environment and human health, especially in industry like oil and gas. Thankfully, a revolutionary green solution exists, which is chitosan-based corrosion inhibitor. It is derived from crustacean shells. Chitosan is a natural biopolymer offering a groundbreaking approach to pipeline protection. Unlike its chemical counterparts, chitosan boasts impressive eco-credentials. It decomposes completely, leaving no harmful residue, and is non-polluting, minimizing environmental impact. This makes the clear choice for companies seeking a sustainable and responsible solution. For the next part, which is motivation and problem statement. Keeping pipelines safe is crucial, but current methods using harsh chemical harms the environment and human health. This pipeline constantly under attack from corrosion caused by moisture, gases, and temperature changes are vital for transporting resources. Corrosion weakens pipelines, increasing leak risk and environmental contamination. It also poses a health threat, especially in industry like oil and gas. Conversely, chemical inhibitors, while effective, are a double-edged sword. This, this toxic chemical risk human exposure and pollute the environment. Thankfully, chitosan, a natural and biodegradable alternative, offers a promising solution. However, research is needed to optimize chitosan-based coating for cost effectiveness and maximum corrosion protection, making it a truly viable and sustainable option for the future. This is our objective of this project. The objective of using a cytosan-based corrosion inhibitor listed below is the main objective of the project. First is to examine the application condition necessary for cytosan-based coating to perform optimally. Example of this include looking at things like substrates compatibility, variation in weather condition, and different application methods. The goal is to identify the best condition for maximizing this coating capacity to prevent corrosion. Second, to investigate the long-term maintenance saving, application costs, and material costs as you study the engineering economics of cytosan-based coating. When comparing the formulation to traditional corrosion prevention method, aim for an economical option that yet provides exceptional corrosion protection. The last objective is to conduct out a comprehensive analysis contrasting cytosan-based coating with conventional corrosion prevention techniques. Consider material costs, application costs, and long-term maintenance savings to have a true grasp of the financial viability of chitosan-based treatment option. This comparative research aims to illustrate the economical and technological advantages of coating based on chitosan as a corrosion control method. Now I'll pass to the next presenter.
For the market survey analysis, we are using four types of corrosion inhibitor, include chitosan. For the second is Nippon pen. For the third is Carlo Pro 2K epoxy. And lastly, protective coating 7 epoxy paste. They have different price because it has different feature. For the chitosan, it is biocompatible, antibacterial, and environmentally friendly. For Nippon pen, has good durability, fungus resistant, and excellent gloss. And for Color Pro 2K, It has good adhesion and anti-rust. And lastly, for the protective coating, the bond and repair stainless steels, bond metal electrical boxes to concrete wall, and waterproof heavy duty.
Next, I will proceed about project capital cost estimation. There are three main ideas we have focused in this project. First, types of cost, phase analysis and impact of cost estimation. For types of cost, first, material cost for creating hybrid chitosan or silica composite and coating. Second, labor cost, wages and number of workers needed for smooth plant operation. Third, equipment cost, which equipment needed for manufacturing the composite. Next, phase analysis. First, material preparation for cost estimation required materials. Second, equipment procurement for cost estimation purchasing equipment. And third, labor allocation, cost estimation for required workers and their wages. Next, impact of cost estimation. First, risk management identifies potential risks and plans for uncertainties. Second, resource allocation ensures efficient use of resources and avoid shortage or excesses. Third, decision making helps in making informed decision and assessing project feasibility. Next, we proceed about cost estimation. There are four stages. Stage 1, preparation of hybrid chitosan or silica composite. We have five material types. First, medium molecular weight chitosan. Second, glacial acetic acid. Third, silica nanopowder. Four, ice. And five, cycloaliphatic with amine. And the price based on the market analysis and our survey. There are examples on how to calculate medium molecular weight chitosan, glacial acetic acid, and cycloaliphatic amine. As example, how to calculate medium molecular weight chitosan at concentration 1.5%. First, 0.000625 kilogram per hour times with 24 times 30 and times with 0.95. 24 is convert hours to day, 30 is convert days to months, and 0.95 accounts for 5% reduction, and then we get 0.4276 kilogram per month and 0.4276 kilogram per month divided with 0.25 kilogram and we and then times with current price RM 1770, we get 2936.76 ringgit. For stage 2, preparation of composite coating. We only use one material, which are epoxy resin. There are calculation of total cost for sample preparation for 3 months. So for raw material, we get 17,388.93 ringgit. For stage 3, cost of labors, we use formula Al-Kayat and Girod. Average wage of lab assistant in Malaysia, 7 ringgit and 50 cent per hour. Duration of project is 3 months, which is equal to 90 days. Wages in 3 months is 15,390 ringgit. Therefore, cost of labours is 184,680 ringgit. Stage 4, equipment purchase for sample preparation. We use 5 equipment: centrifugal pump, metal vertical vessel, disc and drum filter, impeller mixer, auto batch separator centrifugal. We use two formula: total model cost (CTM) and bare model cost for each equipment (CBM). CBM for centrifugal pump is 8,623 ringgit. CBM for metal vessel tank is 35,310 ringgit. CBM for disc and drum filter is 30,149 ringgit. CBM for impeller mixer is 5,469 ringgit. And CBM for auto batch separator centrifuge is 91,643 ringgit. So total model cost is 202,022 ringgit point 48 cent. Next calculation of cost of manufacturing is 561,928 ringgit.
Next, I will proceed with performa cash flow. It consists of three main points, which is raw material cost, equipment cost, and labor cost. For the raw material cost, it consists of medium molecular weight chitosan, glacial acetic acid, silica nanopowder, ice, siloalphatic with amine, and epoxy resin. And the total cash flow for raw material cost is 5,834 ringgit and 90 cent. For the equipment cost, it consists of centrifugal pump, metal vertical vessel, disc and drum filter, impeller mixer, and auto batch separator centrifugal. The total cash flow for equipment cost is 171,205 ringgit 95 cent. And last but not least is labor cost. It consists of lab assistant, which is 12%. The total cost is 15,390 ringgit.
For the feasibility analysis have five scope, which are net present worth analysis, NPW, rate of return analysis, ROR, rate on investment analysis, ROI, cost analysis, and payment period analysis. For the net present worth analysis, we construct of cash flow for each month from 0 to 3, and then we have interest rate in Malaysia, which is 3%. And next we construct the equation of NPW, and our NPW we got here is positive 11,841.15. The project is profitable to proceed since the positive value of NPW analysis is positive. So next we will calculate the ROR. To calculate the ROR, the NPW must equals to 0. So our equation will be like this, and we must to guess the interest. Our first guess is 10%, and we got negative 1,353.20 for NPW for the first guess. For the second guess, the interest is 0.25%, and we got the NPW equals to 18,361.89. And then we will interpolate the data so we can get the interest for net NPW 0. It will be our ROR, which is 9.33%. Next, for the ROI, the equation is net present worth minus total cost of manufacturing divided by total cost of manufacturing, and our ROI is negative 0.97. The ROI have negative indicates that the loss of investment over 3-month period of the project starts is 98%. Next, for the cost analysis, we have 4 types of corrosion inhibitor with different price. So the chitosan is more expensive than other inhibitor but performs best in preventing corrosion. Research and experiments show chitosan is very effective, providing long-lasting and strong protection. Chitosan can be used in various forms like coatings, films, or composites, making it suitable for different applications. Chitosan is more expensive than other inhibitor but performs best in preventing corrosion. And lastly, chitosan is best choice due to its effectiveness, durability, and versatility. The initial cost is justified by long-term savings, better protection, and sustainability, making it the preferred option for corrosion prevention. And lastly, we will calculate the payment period analysis. The payback period will have the formula fixed cost divided by net revenue, and our payback period is 1.32 months.
So this is the Gantt chart for our research planning. So we will start with the research proposal drafting and we end with the partial thesis writing at week 14. Next we will move to conclusion and recommendation. From our project we can conclude that research on chitosan based coating is vital for tackling corrosion issue in engineering and industry. This is important because carbon steel is widely used in pipes and corrosion damaged structure. Chitosan shows promise a corrosion inhibitor due to its strong adhesion, biocompatibility, biodegradability, and antibacterial properties. However, we still need more knowledge about how to make and use this coating effectively. And next is recommendation. We have three main points, which is further formulation study, environmental impact assessment, and last but not least, real world testing validation. For further formulation study, we want to understand chitosan based coating, truly investigate their structure and chemical composite, study variation in chitosan concentration, distillation, and additive to improve corrosion prevention and optimize performance. For the environmental impact assessment, analyze the environmental impact of chitosan based coating through their life cycle from manufacture to disposal. Identify ways to improve sustainability and modify formulation to reduce environmental impact, ensuring compliance and current environmentally friendly technology standard. Last but not least, real-world testing and validation is to evaluate the performance of chitosan-based coating, conduct extensive field tests in various industry settings. This will provide data on adhesion, durability, and corrosion resistance in different conditions. Adjust formulation based on the result to ensure they are practice and reliable for real world use. That's all from us. Thank you.